Dear students, welcome back to the family of quadrilaterals. In this period, we will see a few more theorems and examples related to parallelogram. Just one more theorem. A quadrilateral is a parallelogram if a pair of opposite sides are equal and parallel. A pair, they are only talking about one pair, but at the same time, they are equal and parallel. So this is a given condition. Now we have to show that this is a parallelogram. So let us construct a line and let us name this parallelogram ABCD. From triangle or in triangle ADB and triangle CBD. We are given that AD is equal to BC. It's given to us. We have a side now. Next, we already have BD is common. So we have another side now. And now we have to make use of the parallel sides. And you know, when lines are parallel, we can apply either corresponding angles or alternate interior angles. So let us see the alternate interior angles here by looking at the Z shape. So we have a Z, the angle ADB is equal to CBD. Angle ADB is equal to angle CBD. So we have an angle now. So what is it? One side, one angle, and one side of a triangle is equal to side, angle, and a side of the other triangle. So by SAS congruence rule, triangle ADB is congruent to triangle CBD. As I always say, we have to be careful while writing the second part. DB and BD are common, so we have to write it in the same way. So we get these two triangles are congruent, and what is the task that we have to do to show that it is a parallelogram? Now in this triangle, we know that the side AB is equal to DC. AB is equal to DC or CD. AB is equal to DC. Corresponding parts of congruent triangles are equal. So we have another set of sides in this shape are equal. So we get that both pairs of opposite sides are equal in this shape. Therefore, ABCD is a parallelogram. The reason is that both pairs are equal. Opposite sides are equal. Here it's given that ABCD is a parallelogram in which P and Q are the midpoints, which means the left and right of Q are equal. Also the left and right of P are equal. And it's given that ABCD is a parallelogram. So we know that the side DC is equal to the side AB because they are opposite sides of parallelogram. Therefore, half of equal sides, which is QC, is equal to AP. Because Q and P are midpoints. Now, the first part, we have to show that APCQ is a parallelogram. Here, we know that QC is equal to AP and QC is also parallel to AP. Why is QC parallel to AP? Because DC is parallel to AB because it is the opposite sides of a parallelogram. So if the full line is parallel, then a part of the line will definitely be parallel. So from these two parts, we get APCQ is a parallelogram because one pair of opposite sides are parallel and equal. All right, so we proved the first part. Next, we have to prove that DPBQ is also a parallelogram. Again, we know that DQ is equal to PB because that is also half of DC equals half of AB, opposite sides of a parallelogram. Again, we have DQ is parallel to PB because it is a parallelogram. It's a part of DC parallel to AB. So if the full lines are parallel, part of the line will also be parallel. Again, therefore, we get the answer DPBQ is a parallelogram because of the same reason. One pair of opposite sides are equal and parallel. Now the next part we have to prove is PSQR is also a parallelogram. PSQR. We already got that DPBQ is a parallelogram. So PS and RQ are the opposite sides of this parallelogram. So we can say PS is parallel to RQ, PS parallel to RQ because DPBQ is a parallelogram. Since DPBQ is a parallelogram. So we found that these two are parallel. Again, SQ is parallel to PR. Also, SQ parallel to PR because we found that APCQ is also a parallelogram. Since APCQ is a parallelogram. So right now we got opposite sides are parallel. Both the pairs of opposite sides are parallel, which means PSQR is a parallelogram. Therefore, PSQR is a parallelogram. But here the reason is not about one pair. Both the pairs are parallel because both pairs are parallel. All right. Let's move on to the exercise 8.1. The angles of a quadrilateral are in the ratio 3:5:9:13. Questions with ratios. We have seen it before in the chapter triangles. Whenever we have ratios, we can replace it by a variable throughout for all the numbers with the ratio. So let us replace by x with all these numbers. So we can find that all of the angles are in the ratio just randomly 3x, 5x, 9x, and 13x. It is just a quadrilateral, means four-sided means four-sided polygon. And we have studied that the angle sum property of a quadrilateral will give you 360 degree. So we say 3x plus 5x plus 9x plus 13x all together should be 360 degree. And the reason is angle sum property of a quadrilateral. So we can add all of these because they have the same variable. So it will be 8 plus 9, 17 plus 13 is 30x is equal to 360 or x is equal to 12. Now we can find one by one. First angle will be 3 times 12. Second one will be 5 times 12. And the last one will be 13 times 12. These are the angles, which will be 36 degree, 60 degree, 108 degree, and the last one will be 156 degree. And when we add all these numbers, you will get the answer 360. So these are the four angles of this quadrilateral. Moving on to the next question. If the diagonals of a parallelogram are equal, then show that it is a rectangle. So condition is that it is just a parallelogram, which means opposite sides are equal and parallel only, and the diagonals are equal. So these two sides are equal. Now we have to show that it is a rectangle. A parallelogram is a rectangle when one of the angle is 90 degrees. So the question is to show that one of them is 90 degree. For that, let us consider these two triangles from the parallelogram PQRS. So in triangle PSR, the yellow triangle, and the green triangle, which is QRS, we know that PS is equal to QR because they are the opposite sides of a parallelogram. And QS is equal to PR. It is given to us the diagonals are equal. And RS is common. So we have three sides now. So by SSS, congruence rule, these two triangles are congruent. PSR is congruent to QRS. So we can find that angle PSR is equal to angle QRS, corresponding parts of congruent triangles. Now, angle PSR plus angle QRS is equal to 180 degree because of the rule same side interior angles in a parallel sides. But these two are equal, so we get angle PSR is equal to 180, or each of the angle is equal to 90 degree. So if at least one of the angle is 90 degree, the parallelogram changes to a rectangle. So what was the condition given? The diagonals are equal. So if the diagonals are equal in a parallelogram, it will change to a rectangle. That's what we have seen in this example. Moving on to the next question, show that the diagonals of a quadrilateral bisect each other at 90 degree, then it is a rhombus. So this is just a quadrilateral, but they are bisected and each of the angle is 90 degree. We have to show this is a rhombus. This changes to be a rhombus if all the sides are equal. So for that, let us take the triangles. Triangle PMQ and triangle PMS. These two triangles are congruent by SAS because PM is common. QM is equal to MS, it's given. And angle PMQ is equal to angle PMS is 90 degree because they are right angles, it's given. So side angle side by SAS, triangle PMQ is congruent to triangle PMS. The task is to show that it is a rhombus. PQ is equal to PS. PQ is equal to PS. Corresponding parts of congruent triangles are equal. Similarly, when we consider the triangle PMQ and QMR, we can also show that similarly, we can also show that PQ is equal to QR and QR is equal to RS, which means all sides are equal. And also opposite sides are equal. So first of all, we can say PQRS is a parallelogram because opposite sides are equal. And we have studied that in a parallelogram, if all sides are equal, it will be a rhombus. Therefore, PQRS is a rhombus because all sides of this parallelogram are equal. Okay, so we have proved that PQRS is a rhombus. Moving on to the next question. Show that the diagonals of a square are equal. So this question has three parts. We have to show that the diagonals are equal, they are bisected, and each of them are bisecting at 90 degrees. The only given condition is that it is a square. So consider the square ABCD. So we will prove in three cases. First, we will prove that the diagonals are equal. For that, let us take the triangle ADC and triangle BCD. In these two triangles, we know that BC is equal to AD because it is a square. We have a side now. Side CD is common. So we have another side now. And we know that angle ADC and BCD are 90 degree because it is a square. All the vertices of a square are 90 degree. So we have side, angle, side. So by SAS, triangle ADC is congruent to triangle BCD. Now, by CPCT, you know that the side AC is equal to side BD. AC is equal to BD. Therefore, the diagonals AC and BD are equal corresponding parts of congruent triangle. So we have shown that diagonals are equal. That was the first part. Now we have to show that they are bisected, means these two are cut into two equal parts. Let's see case 2. Now we are going to show it is bisected. For that, we have to take the triangle. Let's consider this is O. So in triangle AOD and triangle BOC, our task here is to show they are bisected, which means we have to show that BO is equal to DO. This is the task. So first we will show that these two triangles are congruent. Because this is a square, the sides AD and BC are parallel. AD is parallel to BC because it is a square. Opposite sides are parallel. So we know that angle ADO is equal to angle CBO. CBO. Alternate interior angles. Because they are parallel, we mentioned it here. So we get one angle now. Also, we get the second angle, which is angle DAO is equal to angle BCO. The same reason. Again, they are parallel. And we know that AD is equal to BC because all sides are equal in a square. So we found that one angle, one side, and an angle. So by this is an angle, and a side. By ASA, congruence, triangle AOD is congruent to triangle COB, because the angle which appears at A should be equal to C. Now we can see that BO is the same as OD. Therefore, OD is equal to OB, corresponding parts of congruent triangles, which means the diagonals are bisected. Actually, we showed only OD and OB. Also, we can say that AO is equal to CO from the same. AO and CO, they are equal. Also, AO is equal to CO. That's how both of them are bisected. So we have shown the second part. Now again, we have to show that each one is bisected at 90 degrees. So let's see the third case where the shape is a square. ABCD is a square. And now it is bisecting at 90 degrees. For that, let's take the triangles AOB and triangle COB. We know that AB is equal to BC because they are the sides of a square. So we get one side. BO is common. So we get another side. And we have just proved that the diagonals are bisected. So AO is equal to OC because diagonals are bisecting in a square. So we have another side. By SSS congruence rule, we have shown that triangle AOB is congruent to triangle COB. which means angle AOB. Therefore, angle AOB is equal to angle COB. Corresponding parts of congruent triangles are equal. At a point, if two angles are equal to form a straight line, it will be 90 degree plus angle COB is equal to 180 degree because it is forming a linear pair. And we have found that both of them are equal. If both of them are equal, we can just replace by one of them. Angle AOB, two angle AOB is equal to 180, or each one of them is AOB is 90 degree. Similarly, we can prove that all of them is 90 degree because here vertically opposite angles, these two are 90, these two are 90. So diagonals, therefore, diagonals in a square are equal. We proved it. They bisect each other. We proved it. And 90 are at and bisect at 90 degree. We have proved it. So this question is explained in 3 cases: case 1, case 2, and case 3. Hope it's clear. Keep practicing. This is just easy once you understand which triangle to be taken to be proved which are congruent. That's all for today. Thanks for watching and see you later.